I am Dr. Chandra Jagan Mohan, and we have been discussing about the different methods of electrical power generation. So, in that, majorly we are having two categories, that is conventional and non-conventional. In the non-conventional, we have been discussing about the solar energy. So, we have discussed about the physics of the sun. So, what is the size of the sun? What are the gases involved there? What are the gases involved there? And what is the size of the sun? What are the layers of the sun? So, how much energy is reached to the earth and how much is filtered by the atmosphere of the earth. So, all these things we have discussed. So, how the solar energy varies with the varying of the sun, movement of the sun, the varying of the seasons, with the varying of the clouds, all these things. So, here and we have, after that, we have discussed about the solar thermal. So, in the solar energy, there are basically two types. So, that is solar thermal energy and photovoltaic energy. So, we have started the solar thermal energy, and we have discussed about the different collectors, reflectors, concentrators in the solar energy. So, if any system, today's topic is off-grid solar power system. Let's move into the topic. So, any system, if we are generating for the purpose of isolation, that means the power which we have, the power which we are developing is not connected to the grid. So that they are called the standalone systems or off-grid systems. They are called the standalone systems or off-grid systems. So here, so for example, so our topic is the solar energy, the off-grid solar energy or standalone solar system. So I'm having for example, so we are having different sources of generation. For example, I am having a small hydropower plant where I am generating a small amount of power, and it is not connected to the grid. So it is only supplying some amount of, it is only generating a small amount of power, and we have constructed for a small village. So we can say it is a standalone hydropower system or off-grid hydropower system. And similarly, if I am doing similarly for the solar system, if I am doing similarly for the solar system, it is called as solar. So if I am doing similarly for a steam with a steam power station, thermal power station, only I am generating the power to supply to run a village or to run a industry. So that is off-grid thermal power station. Similarly here also the solar power station. So you can easily understand that. So solar power system. So normally we are going for the solar thermal energy. Okay. See, solar thermal energy we are generally utilizing for the house purpose. Okay. We are not generating them to connect to a grid. So except in the utilization of the heliostats. Okay, so the solar thermal energy is uh, majority for less amounts of power. They are also off-grid. Okay. So similarly, here also we are having that facility. See, the even in the solar thermal energy, the equipment is very uh, much highly needed when compared to this photovoltaic. So here solar means we are talking about the photovoltaic PV sets, PV modules. You can observe. See, this PV module are very portable, very simple. We can carry them. So we can even use these PV modules just for charging a cell phone. So this much of facility is there in the utilization of the solar cells. So just for carrying a laptop, for supplying the power to the laptop, just for supplying power for some two bulbs, like that. See, this much of facility, this much of simplicity uh, of utilization is not possible in other things where the power is generated. So the small amounts of power we can use with the PV sets. Okay, so they are all the applications here. So generally, if we are talking, we will talk about a series of modules. We are not going to for a single plates. So many modules we will talk. So that may be supplying to a village or some part of a colony or some houses. So generally we will tell example as this, but even to the lower level we can move. So what are those things we will be knowing in the coming PPTs. Okay. So here we will be having generally any module will be off-grid solar power system. Generally, so modules connected, and we'll be having a solar charger, and afterwards we'll be having a battery bank of batteries. So where the power which is generated during the daytime is stored, and solar inverter. Okay. Generally, the power which we are getting is the DC power. So this DC power is only useful for the equipment which is run by the DC power. So normally our equipment is designed, majority of the equipments are designed to work under the AC power. So we need a inverter here. So if sometimes the power, because it is off-grid solar power system, so generally we will be planning for the less amount of we will be planning for the less amount of power generation. Sometimes if the it is cloudy, so due to some the sun is not that much of brighter, so the power shortage will be there. A small power shortage will be there. So that shortage we can manage if we are having a diesel generator in such cases. So that is also uh, there in this system for facing such type of problems. So this is generally uh, layout of a stand-alone solar power system. So stand-alone system, if you are talking itself, if you are talking itself means, so it is an automatic. So we are not giving any supply to it. So it is that energy is stored in the batteries, and afterwards we are using to the utilizer, maybe for a house, maybe for a group of houses, maybe for a small village. So that is called as so generally uh, the solar power we will be using in the remote places or rural places, because no other uh, system is this much of comfortable to be generated in that remote places than any other system. So if you have observed, so the governments uh, wanted to educate the tribal people which who will live in very remote places in the jungles. So they have provided this solar equipment, and there they have produced the power, and there they have given there they are giving education to them. So in other cases, without having supply from the outside, so transmission lines, all these things, so it is a simpler thing. So that's why this power is more, the solar power is more successful in the rural places and in the tribal places than any other places. So that is the one of the very good benefit in this solar power system. Okay, because other things are impractical. Other type of power generations are impractical to be used as much as the solar power in the rural places. See, generally they will be having batteries. So these bank of batteries, uh, they will be they will be storing the power which is produced during the daytime, and they will be using in the night time. Okay. So they will be having a capacity generally of 12 volts, 24 volts, 48 volts. So like that. So next thing is a charge controller. So this helps to control the charging of the batteries. So excess charging of the batteries. This regulates and controls output from the solar array from being overcharged. So sometimes it is optional. So sometimes you may be having this charge controller, that is optional, but it is best to have in the angle of a safety reason. The angle of a safety reason. So next thing are fuses and isolation switches. So this will generally this will be using in the for the proper protection in any system. So this allow PV installation to be protected from accidental shortings of wires, allowing power from PV modules and system to be turned off when not required, saving energy from the so we can just switch off, and sometimes they will isolate from the high power. So next thing is wiring. So this is also an important thing for PV system, which is electrical wire. So where there is electricity, the wiring is there automatically. The cables need to be correctly rated for this. So if you are having a wiring, the wires with the suitable configuration we have to install. So if the power is more and we are connecting a less capacity wires, they will damage. They will be naturally they will get damaged. So some people may think they can use the telephone wires. So that's totally off. cannot use this telephone wires in our electrical system. So inverter. So inverter is the essential thing. So without this inverter, a standalone system maybe will become a system which can meet only the demand of a equipment which will run only by the DC power. So this is very, very important. And in other cases, what is happening? What is that? So we will generally develop AC power. Automatically, AC power is developed. So even if you go to the wind power also, so wherever there are turbines, we are generating the AC power. So here we are generating DC power. So, but our design system, our utilization system, our utilization equipments are totally designed to work with the AC current. So, for that purpose, the inverter is needed, which will convert this DC into AC power. So, what are the applications? So, the applications are that is all the AC applications, that is washing machine, TVs, and freezers, etc. So, if you go to the off-grid applications, see, always we may be thinking that the off-grid applications or standalone applications means some big amount of arrays and battery system, all these things, some lots. So even we can go for much smaller applications also. So generally a standalone system will be there to meet the requirement of a house or a industry or a small village. So, but we can go to further lower level of standalone system. So that is we may be using here for the homes, for the clinics, for the schools, for the rural business, for the tourism, for solar water pumping, and mobile charges, and telecom, and radios, and street lights, and mini grids, and small portable appliances. So we can go for much smaller applications than a village, so, which is more comfortable. See, if you go to the first thing, so that is okay. The system, that is standalone system, which we have discussed here. So this system, it is having a much equipment. So many PV arrays and a charge controller and a battery bank and an inverter and a generator. So this is good. If the utilization is for houses, so where the people are not moving, so they are stable. So if you go to the utilization for mobile utilization, so if you observe here, so here what is happening? So he is a juice seller, so he cannot stay at one place. So he wants to run his machine, juice machine, with PV cell. What he did? So at the top, he has installed the PV arrays, and with that, his machine is working and he is selling the juice. So it is much simpler application. So we have to decrease this off-grid solar power to much simpler applications. So if you go to this house, okay, only for a single house. So it is very remote. So that we can observe from this location. So it is away from the normal inhabitations. So here also we can use. Similarly, we can use for industrial applications. For industrial applications also we can use. So much more simpler, that is solar lamps. So that is compact fluorescent bulbs, LED lamp, and rechargeable. So normally the batteries which we are using here will be the rechargeable batteries. So the rural entrepreneurs. So we should not think that entrepreneurs will be always there in the urban areas. There will be entrepreneurs in the rural areas. So for the people, such kind of people, this standalone or off-grid solar power is very much useful. And also, if you go for much more amount of production, we can say we can call it as a microgrid. See here, off-grid, small portable appliances, very small. See, solar lanterns, Pico solar power supplies for laptops. See, so I can have a small plate, PV plate, and I can connect this to the laptop, and then I can charge this. So along with the laptop, I can carry this small PV plate. So I can move to any place. So if you neatly observe this diagram, so this man has placed a small plate, solar plate, and he has given supply to that small hut. So this is from the Africa. So where the governments, where the countries are very backward countries, so they may not construct the dams to produce the hydropower. They may not construct the thermal plants to produce the power. So, but any person, if he wants to help, if he wants to give supply, electrical supply to them, so a single person, even a single person can do that. So normally, if you want to do this type of thing, what will happen? So you have to construct a dam, or you have to construct a thermal power station, and you have to place the transmission lines, and you have to supply there. So that is practically very tough. So if you go with a solar panel, it is very simple. So that's why the solar panels are much more practical. Solar power is more practical power we can use in the remote places. See, these people are the tribals, the Maasai tribals. They will be always migrating. They will construct also the huts with the small vegetation there, and after that they will leave that place. So even to them, we can practically give supply. So that is Pico solar system for the lamps and the laptop, and also we can give light for those people, lanterns during night, and they can use solar lanterns. And also you will be having some type of equipment. So there is a person somewhere away from the normal civilization. So he's suffering with severe health problem. So the doctors have to go there. So some medical equipment, they have to be in the cool place. Okay. So such type of equipments need cooling. So refrigeration, small refrigeration. So there also you can use this type of uh, small solar panels. So lighting purpose, low power medical equipment, refrigeration, cold chain, vaccine, cold chain. Some generally the vaccines, so they should be stored in a cool place. You can observe. So this is our ATM. So which is connected to the grid. So this is the ATM which does not require any external electrical supply. So simply with the help of this solar panels, this ATM will work. So that is also a very good application. And street lights, everybody is aware of the street lights. Okay, public squares, roads, private airports, all these places will be using these street lights. So and also water pumping. Okay, for water pumping also we can use the solar panels. So you can observe here. So this is the panel. So it is absorbed in the sunlight. The photo working with the photovoltaic effect, and these PN junctions are producing the power, and with that power the motor is functioning. The pump is pumping the water and storing it in the overhead tank, and afterwards we will be using the just water maybe for agriculture or some other purposes. And this is you can use this for water drinking also. Okay, so we can pump the water, good water, and we can use it for drinking purpose also. So you can use this in the tourism also. So the boats, generally what happens if you go to the lakes, so there we can use the solar panels and we can move those boats. So we can use this in the national parks, large potential market, noisy generators. So generally other including the solar thermal power, we need a generator. Generator means generally we are getting the sound pollution, that is noise. So that is also permanently deleted. We can permanently remove that problem if you are using this solar panels. So this is a mini grid. So if you are supplying for a village, generally we will call it as a mini grid. So you can observe here are the panels. We are having the inverter to convert that DC power, which is normal. So except this photovoltaic here, the PV power everywhere will get the AC. So that is only the problem here. So here we will get the DC, and we have to use that inverter convert into AC. So after that, we are supplying it to the houses, and we are running the. See what we will be having generally. We will be having the arrays, we will be having the battery bank, we will be having the inverter, we will be having the charge controller. Okay. And we will be having the fuses. Okay. All these things are generally will be there. See, so we have talked about different applications, and we have discussed about the general off-grid solar panel. So if you want to divide this off-grid solar or standalone solar systems, so we can majorly divide into 4 categories. See, the first we have started with the solar panel, okay, and a equipment which can work under the DC power, that is DC load. So this is very simple. So we have, so after that, so the first thing is the standalone PV system with only DC load. So that means we are having a PV system, that is panels and a load. So this is the first thing. So after that we have thought for increasing it for better utilization. So we have added something extra for this PV system which only useful for DC load. So we have added extra thing, that is the electronic circuit. Okay, generally this circuit will regulate the power supply maximum, or it will help in the maximum power tracking. So that means we can use more DC equipment, more types of. So here these PV cells will produce some amount of power. So DC power. So we will use the equipment which is suitable for it. So if there are some equipment which are sensitive, that DC power is more to them. So then we have to decrease, or sometimes we have to increase. So if you want to use it effectively, so we have added this circuit here. Okay, so we are using more DC loads here, more types of DC equipment with the help of the circuit. So this is the second type. So for that, again, so these PV cells are producing power, and the DC equipment we are able to manage the requirement of this different types of DC equipment with the help of the circuit. So what happens is sometimes that may be cloudy, so it will be decreasing. So sometimes we have to use it in the night times, during the night times. So without this, for that we need battery bank. So without this battery bank, we are able to use it during the daytime effectively with the adjustment capacity of the circuit or more equipment. So even if you want to use it during the night time, or sometimes suddenly the power decreases because of the clouds. So what happens? So this battery bank will help to meet this equipment. So the third thing is standalone PV system with the DC load, with the electronic circuit and battery. Okay. So this thing up to here, okay. So we are very good. We can supply power for DC loads even in the night time, even in the uncloudy time we can manage with the help of this battery bank. So what about the equipment? So generally what happens? So the majority of the power options we are having. If you go to hydropower, if you go to thermal power, if you go to wind power, so generally they all will produce the AC power. So our equipment, which is designed, most of the equipment is designed to work under the AC power. So all those remaining methods will produce the AC power. So majority of the equipment are designed to work for the AC power. So this is the very lagging thing here. So we cannot meet majority of the equipment, majority AC load demand. So if you want to meet this AC load demand, we have to use inverter. So standalone system with circuit, standalone system with AC or DC load? No. So it can supply AC or DC. And electronic circuit and battery bank and a inverter. So this will become a standalone PV system. AC DC load. So up to here only DC load. Here, since we have added the inverter, it will become a AC DC load. So remaining things are same. That is electronic circuit and battery bank are same. So totally there are 4 types of standalone systems. So the standalone system with DC load, standalone system with DC load and electrical circuit. Next, standalone system with the DC load, electrical circuit and battery. Next, standalone system with AC DC load and electrical circuit and battery. So totally there are 4 types of standalone systems in the solar system. First we will go to the standalone system with the DC load. So only DC load. So if you see this diagram here, so there is the load. This is the DC load. Okay. So the power which is produced, it will run directly. With this power, the fan will directly run. So in middle there is no any other mechanism. So it will only run with this power. We cannot increase or decrease. We cannot regulate the power which is supplied to this fan. So, but this is the simplest thing. So no extra requirements of battery bank, of inverter, of charge controller, or electronic circuit. Okay. All these extra things are not needed. So this is the simplest among all the standalone systems. So the standalone system is only, so in the name itself it is there. So that is PV arrays and load with only DC. With only DC load requires only 2 main components. What are they? Solar module array, that's all, and the load. So this will produce the power and this will consume the power. Okay. But what is the disadvantage? It will only supply during the sunny time. So when the clouds will come, it will decrease. When it becomes night, it cannot supply. It cannot produce and that's why it cannot supply. So but the configuration is quite simple. So with the varying of the sun angle, the power which is produced here also will be varying. So that is also a problem here. So this makes application of standalone PV system with only DC load limited to some specific electrical appliances where the precise operation is not essential. So only some kind of equipment we can use with this type of generation. So all the equipment cannot function with this type. So what are these? They are the pumping, drinking, irrigation water. As in the both cases, fixed amount of water is not required to lift every hour. So here there is no conditions here. So whenever the power comes, they will work and they will supply. They will work. That may be they will pump the water or they will pump the drinking water or they will supply the irrigation water. So the applications, the amount of applications has decreased. Very small amount of applications are there with this type of standalone system. So next we have gone to a better version. So more appliances. We can use more appliances. So if you simply add a electronic circuit which will regulate the supply or which will act as a maximum power tank. So what is extra? What extra thing came between the previous thing and this type is that is the electronic circuit. So remaining this PV array is same. and the load is same, but the new thing is the electronic control circuit. So the standalone system with only DC load can be improved by adding an electronic control circuit. This added electronic control circuit to the system improves the utilization of power generated by the solar module array. Okay. The electronic circuit is normally the electronic solar controller. So it is a controller. Or we can say voltage or current regulator. So which it will regulate according to the equipment which we have connected, or a maximum power point tracker. So the main purpose of this circuit is to provide the regulated current and voltage. So proper required power it will supply. So some equipments are sensitive. So for those type of equipment, this circuit is needed. So if you observe here, so the extra thing is arrays are module is same, the load is same, and extra thing is the electronic control circuit. Up to here, it is okay. Okay, if the sunshine is better, so first point is it will work. It is good if the sunshine is good, and the load DC load have the equipment DC load equipment won't have any major constraints. No need of regulation there. So here is we have improved to the better version. So we'll be having a controlled supply. So where we can use now more applications, more equipment. So but now also the problem is this will only function when the sunshine is good. So number of appliances, we have expanded to small applications to the more applications, but still something is lagging, that is it will function only the sun is good. So what we have, and it cannot supply during the night time. So we need something to charge this, to store this energy. So that is the battery pack. So that is the third type of standalone system. So which is having, that is solar standalone solar system with the DC load, circuit and battery. So what extra thing has came is added now, that is the battery. So what is the benefit here? The benefit is we can able to supply DC load even in the night times, even when the sunshine is not good. Sometimes sunshine will go, and sometimes the sunshine will be brighter. So this is the added advantage here. Okay. So now what are the things, that is solar array, circuit, battery. This is the new thing. DC load is as previous. So you can observe here array, load, circuit, controlling circuit, battery. So now this is very good, but still we are lagging in some applications. That is that. So now we are able to supply for more applications. We are able to supply even in the night times. But what is lagging is that we cannot supply for the equipment which will function only with AC power. So the majority of the equipment are designed to function with the AC power. So this is a big lagging. So for that, meeting that demand, so we have gone for a new type, that is standalone system with AC DC load, electronic circuit and circuit battery. So what we have done here is that only the thing is that we have added another equipment here. That is the inverter. That is the inverter. So now the DC power which is coming will be converted into AC. So now the last thing is the final thing is the complex but best type of standalone system. So which will supply. So here you can see DC fan and AC fan. So it will be able to meet the demand of DC and AC. It helps to function both the DC equipment and AC devices. Both devices it can run. So now we can meet the it will be useful for both AC and DC, and also during the day, during the night time, and also with a good power regulation. So all these are the different types of standalone system. So we have slowly step by step we have increased the utilization and we have decreased the disadvantages. So it is the thing is that the solar standalone is the best for utilization in the rural areas than any other type of power generations. Thank you for listening. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.